already told you 0 look like.
Minus 35.
Yeah, so this means sub 0 into the f function first, and then when you get that answer, sub that into the f function again. So we start off with f with 0 put in it, which is our first bit, and we go 6 times 0 minus 5, and we get minus 5 out. We then use that as our input into the f function again. So a function into a function, or a number through two functions, and we get 6 times minus 5 using the same function. Minus 5, which gives an answer of minus 35, and that is the answer to that. Very good. And we could do that. You're well used to this from GCSE. The only difference in terminology is this f after f, which in GCSE would be written like this, wouldn't it? Something like that. Was that it? Yeah. I think so. That's. I thought it was like the f only one part. Yeah, it could be. Yeah, I can't remember. We don't need to remember it anyway because it's going to be written like that now in future, which is great. So you're well able for composite functions. Concept of something called one-to-one or many-to-one functions. Let's see, can you figure it out? One-to-one is for each x, there's only one y. For each y, there's only one x. Many-to-one. Huh. What? That's what I said.
So what about the none-to-none to one-to-one?
If a function is many-to-one, it does not have an inverse function. What? What does that even mean? That's very confusing. It's okay. Lexi's going to tell us what it means. No? Yeah. It's confusing, eh?
So we said what?
All right.
Okay.
One of these is a one-to-one function, and the other is a many-to-one function. Which one is?
One is that one.
This one?
Yeah.
Correct. Why?
Because it only has one value of y. And
Yeah. Yes.
And, yeah.
Every x has an individual y, and there's no double y's for the x. This one, I can get two y values the same for two different x values.
So how does that not have an inverse?
Because of the thing we said yesterday. Remember, inverse then would have to be reflected in this line, which would make this shape, which fails the vertical line test.
Yeah, if we have to translate a graph.
So it can be, you will not be asked to visually do it like that. Trying to think, have I ever seen it? Not that I.
Rotate a graph?
Can you rotate a graph?
Yeah.
Well, of course you can, but you're not going to be asked it. Yeah. Okay. So that's the difference. So one-to-one means that there won't be double y values for one x value. Okay. And you can see now why its inverse wouldn't be a function. You could draw it, but it wouldn't be a function because it doesn't pass the vertical line test. Okay. That's the wrong way. And now we talk about inverse. First of all, how do we get an inverse?
By substituting y for x.
Exactly the way you did in GCSE. You swap the y's and the x's, and at the end you swap back, and you do call one f inverse. You don't call it. Let's just do an example. Maybe it might be easier. So let's say we have a function. Let's use one of our rational functions. We have something like this. We have a rational function. We need to swap all the x's and the y's. This is quite tricky. So we get the inverse of this. This would be called this. And we are looking at f inverse x. Do not get confused with f1x, which is actually a different thing. What's that one, Aiden?
Derivative.
Yeah, that's the first derivative from calculus. This is the only, he's done AP, so this is the inverse. This is what we're looking for. So how do we make that reflection y equal to x? Same thing as you did in GCSE. I would probably swap all the x's and y's. You don't have to do this, but I have something like this, swap. Okay, x's and y's have been swapped. And now I'm going to solve it for y. I'm going to multiply both sides by 2y plus 3. I get 2xy plus 3x is equal to 2y minus 1. Panic. There's two y's. What do I do?
Factorize.
Factorize. Very good. 2xy minus 2y. I bring the y's to the same side. Okay, I got minus 1 minus 3x. It's not too nice. You can change all the signs if you want. I'm not going to do that. But I am going to factor out y. I'm left 2x minus 2. And then divide by this. Minus 1 minus 3x, 2x minus 2. I didn't write that very well. And of course, in the exam, I wouldn't leave it like that. I would write f inverse x is minus 1 minus 3x. You could lose a mark, yeah. Yeah, it's a bit like end of proof by induction if you don't write the thingy. I know, pretty annoying. Math is annoying? Oh, sorry. Key property of the inverse and its original is the x's and the y's have been swapped, haven't they? The domain is now the range, is now range, and range is now domain. So Google Chat. So that comes up, it can be a quick way to solve it if you know the output is now the input. So for example, if I see something like fx equals 7, and I already have done the inverse, what can I do? I can do f inverse with 7 put in it will get me what x is. Does that make sense?
Yeah.
That was a concept that did come in GCSE as well. Inputs are outputs, outputs are inputs, x's are y's, y's are x. It's opposite day with the inverse function. So it can help you solve some problems.
Sir,
Yes?
you wrote 2y plus 3
Oh.
on
Did I mess it all up? Oh, I did mess it all up. Let's just
Oh my God.
let's just
That's why I was doing it.
Yeah, I'm doing it.
Why
I'm
did you
looking
do
at my
2y
website.
plus 3?
I don't know.
X plus 3.
I don't know, that's what it always was. I don't know what you're talking about.
Oh, okay, whatever.
Yeah, okay. And then we're back to this. Okay, very good. We've we've done all the concepts in that chapter. That's chapter 15. My recommendation is to go to the review set. I'm going to presume you know all the review set for Tuesday's class, that's the starter is going to be the starter. It's just going to, I know, it's just going to be the starter. Yeah. So I'm going to just give you starter questions from the review set for your starter on Tuesday. So you can work through those now if you want. The blue book's over there if you want to use it. Chapter 15.
I don't know about you, sir, but